Hello and welcome back. Previously we talked about how we can model relationships in a database, so now we take a closer look. Our metadata schema describes our data. It describes the entity, like what kind of objects we need to describe. It also fixes the variables, what kind of information we need to capture, and defines the data types, how these variables should be filled. And we define such a schema also with the thought in mind how we can avoid potential data quality issues. Now we need to put all these entities together that we describe in the various tables of a schema. And the relations define how do the various parts of the research data connect to each other. So what do we need to track? We have scientific instruments, and we use the term loosely. We have tools, computers, high-performance clusters, and so on. We also have operating procedures or methods. We can call them protocols or more informally recipes. They can contain experimental protocols, like for example how we prepare a sample or how we cast a sample or something like this, but also configuration details for simulation runs and setups. Then we have the samples themselves, and here again we use the term loosely. We can either have physical specimens that we handle and prepare, but we can also have virtual samples that, for example, are used as input to a simulation. We also have computer code and software versions, not only for our own analysis code, but also the software versions of, for example, the scientific instruments. And then we perform an experiment that we also need to track. And again, we use the term rather loosely. We may have an actual experiment where we do something with a sample, or for example, we take an image in an electron microscope or something like this. But it can also mean we run a specific simulation with specific settings and software versions, or train a machine learning model or something like this. And at the other end, we produce artifacts. That can be data captured from instruments like images, for example, the output of a simulation, a machine learning model, or snapshot log files, and so on. So each of these entities are modeled separately in our database schema. How do we bring it together? You can, for example, think of a simplified experimental workflow. If we have a physical sample, we create the sample and maybe split it into subsamples, and then the sample may be subject to different treatments and preparations before finally we analyze the sample and use some machine learning in the process as well. So here we track everything, right? For example, we track where the instruments and tools are involved and which instruments and tools are involved at which stage of our workflow. We track the samples along the chain, and we have protocols that define how we perform the various steps in our analysis chain. And in the end, we have the artifacts. For example, we take an image. These artifacts themselves may or may not have metadata already embedded in them. For example, you can see here this electron microscope image has a number of settings already stored within the file that we can extract and then capture these data automatically in our research data management system. Because most of the scientific instruments that we are going to use proprietary software, each vendor has their own specific file format. And then either there is already a publicly available reader for these file formats, and then we can use that, or we sort of need to decode what's in the file ourselves if we want to make use of the automatic capturing of data. We also said we want to track our experiments. So if we do a real experiment with a physical sample, then we need to sort of define what we mean. It could be that we use part of the workflow or a larger part of the workflow. That's depending on the use case that you have, and your database schema needs to be flexible enough to accommodate those. If we look at a simulation, we have quite a similar workflow. We also have a sample, but here it's now a simulated one. Instead of scientific instruments, we have computers and code, but they come with protocols or recipes as well, the settings of the simulation, for example. And in the end, we produce artifacts. Here we may not produce an image, for example, but the output of the simulation. And then the actual run of the simulation that can be captured as an experiment as well. So how do we put all of this together? Remember that in a relational database we have a schema and each entity has their own table. The table consists of variables and types, so rows, described in the various entries, and the variables are the columns, and the columns have a definite type. And the links establish relationship, so we can use those to establish hierarchies or parent-child relationships. This allows us to query these entities and relationships. For example, we may want to ask the database, give me back all experiments that were done to a specific sample. Or which subsamples did I create from this sample? Or which kind of treatments did I do for a specific set of samples, and so on. And this can look like this. For example, we create a parent sample, and then we may or may not split this into several subsamples. Then we use instruments to prepare the sample. All of this is modeled in an experiment via links to the corresponding tables. And out come the result of the experiments, for example, numbers that we measure, but also artifacts like an image, and we can then extract metadata automatically and store them in the RDM system. As an example in OpenBIS, this can look like this. Here OpenBIS acts as a sort of front end to our database and makes it easier in a web GUI to interact with it. So here we've entered all the equipment, for example, all the microscope that we have. In our institute we have a number of microscopes, and each of those have an entry in our database. If you click on one of them, we have more information about them, for example, last maintenance or the equipment that is attached to the microscope and so on. We also have our experimental samples. These are subject to many other different experiments, so we keep them in a separate table or collection here. And we also specify protocols. For example, we always prepare samples in a specific way. And if this is general enough that more people use this, or if this is used across different samples, we can put them in the general section for protocol. And then we can also put all the artifacts in one place, and you can see here that if we model an experiment, we have the parents, like for example the samples and the experimental machines that we use. Then we have some free text fields that give the users a bit more information. But we can also link then the protocols and attach the data. If it's small data, we can attach it directly to the record. Otherwise, the data would go to a storage system, and we just link the metadata here. Now we can click, for example, on our sample that we use in the specific experiment. And if we do that, we implicitly query the database and get back everything that has happened to that sample, or all the other experiments that we have already performed. We can also display the information in a hierarchy graph, so we can see visually how everything belongs together. So if we create different entities for everything that is tracked in our RDM system, instruments, tools, samples, experiment code, and so on, we can use parent-child relationships to model these dependencies. That then allows us to query the relationship. But this only works if we are working in a relational data model. Such an approach is not really supported in other approaches, for example, if we base everything on the NoSQL database.